Okay, this is Physics Chapter 2, Problem 63, and it reads, Scientists have studied two species of sand litters, the Mohave fringe-toed lizard and the western zebra-tailed lizard, to understand the extent to which the different structure of the two species' toe is related in their preferred habitats. Fine sand for the Mohave lizard and coarse sand for the zebra-tailed lizard. Figure P2.63 shows a somewhat simplified velocity versus time graph for the Mohave fringe-toed lizard. So that's our graph right there. Then it says, A, estimate the maximum acceleration of the lizard in both meters per second squared and G's. So this is in milliseconds and this is in meters per second. Because we need to find the acceleration in seconds, we need to convert milliseconds to seconds. So we're going to do that now. So we have 50 milliseconds, and then there's 1,000 milliseconds per second. So we got 0.05 seconds. Okay. So part A, acceleration is velocity, change in velocity over change in time. So we have our velocity approximately is 0.75 meters per second minus 0 over 0.05 seconds, which we just converted up there, and that gives us 15 meters per second squared. And it also wants it in G's, so to do that we just divide by gravity, and that gives us 1.5 G's. So we'd say that's the maximum acceleration, because acceleration is the slope of the velocity versus time graph. So for part B, it says estimate its acceleration at t equals 150 milliseconds. So we need to do the same thing. We need to convert our 150 milliseconds to seconds right here. And that gives us 0.15 seconds. And we need a change, so we're going to use our 150 and our 100 to find the acceleration. We're going to go between those two. So we're also going to convert 100 milliseconds to seconds. And that gives us 0.1 seconds. And so for part B here, we are going to put at 150, it's approximately estimated at 1.7 meters per second. And at 100, it's approximately 1.4 meters per second. So we're going to use those values since this is an estimation. And that is over 0.15 seconds minus 0.1 seconds. And once you do that, we get 6 meters per second squared. Or if you want it in G's, again, divided by gravity, and that just gives us 0.6 G's. So that's part B. Part C asks, estimate how far it travels in the first 50 milliseconds. And so to do that, we're going to use the equation x equals the initial position plus velocity initial multiplied by time plus 1/2 multiplied by the acceleration multiplied by time squared. And so we're going to plug in our values for that, and we get x equals, our initial position is 0, our initial velocity is 0, and then so we're left with 1/2 multiplied by acceleration multiplied by time squared. And so we need to find our acceleration at 50 milliseconds, which we did up here, which was 15 meters per second squared. And then multiplied by 1/2. And then our time is 0.05 seconds. And we need to square that. And so we get 0.0225 meters is our distance. But we're going to convert that to centimeters. So we get approximately 2 centimeters.